In today's video, we're going to take a look at variadic functions in C. So first things first, what are those and how can we use them? Well, I'm going to start with a simple example here, and as usual, you know, I like my sum function that I always try to implement, and usually what I do is just I have here it return the sum itself, and I have a couple variables like a, b, and let's say c. All right, and then we can simply just return the sum of all the elements just like that, and we can be fancy and maybe store it in a variable. Why not? And then return the variable, the variable's value, and then when we want to actually call it, we simply do something like sum is %d\n and call sum with, like, I don't know, let's say 1 2 3. Why not? All right, and if we try to launch this, of course I'm gonna get sum is 6 because 1 + 2 + 3 is 6. That's perfectly fine, that works. We all understand this code. Now what happens if I want 4 arguments to be passed to this sum function? How I can actually do that? I cannot just add a 4 here because, well, if I do, of course, when I launch this, it's not going to compile anymore, so it doesn't work. And I guess you can actually pass an array to this sum. So instead of having each argument here listed, we can just pass an int, something like array, and then process it later down the line. That could be a solution, but I want the call, I want the call to actually be on the same line as the printf function. So I don't want to have to create an array first and then pass it over to the sum function. How can we do that? Here's where variadic functions come in. A variadic function is basically a function that can take any number of parameters. You might be familiar with certain functions, such as, well, one that we're actually using here, printf, right? I can simply add another, let's say, %d here, and I can pass another parameter. It takes in any number of parameters. Okay, so printf in itself is actually a variadic function. So let's try to make one. Let's try to make this sum function that we have here a variadic function. To do so, first we have to change the signature. So the parameters are going to be like so. First things first, we're going to have to define here a parameter. Let's call it count. Okay, of type int. So this is going to represent the number of parameters we pass in, and then we say comma space ... That's how a signature for a variadic function looks like. You just have to pass in ... here. Now, since this is just ... how do we actually access those parameters, you might say? Well, we're going to have to include a header here called stdarg.h. This is where we have a couple of functions that help us deal with these variadic function arguments. So to start off, we're going to have to define something of type va_list. Okay, that's where our arguments are going to be stored. I'm going to call it args, so that we know what they are, and we have to also initialize this va list. We're going to do it using the va_start function, and this guy takes in the va list, which we have here called args, and then it takes in the first parameter of the function. Okay, so here we have count in this case. Perfect. Now that it's started, we can actually start iterating over it. To do so, well, we do have the count here, so we're going to actually use it in a for loop. So let's say that we still want to sum all the parameters that are passed here. So I'm just going to say here, let's say int I, and then for I = 0, I less than count, I ++. Perfect. And then I can say va_ to get the parameter. I can say va_arg. Okay, and then here again I just pass in the va list, and in here I have to pass in the type that I expect the argument to be, because really we can pass in any type. We can pass in a string, we can pass in pointers, we can pass in a short integer, we can pass in anything. In our case, we're going to just pass in integers, so 4-byte integers. I'm going to say here int. Okay, perfect, and we can just store this argument in a variable, say int x equals that. So this va_arg function does a couple of things. It looks at the current parameter, variadic parameter that we are at. So we know that here we passed count, so it looks after that parameter, which ones we have in the stack. That's where it starts from. and then it looks at the type that it needs to return. So in this case it's an int, so we know it needs to return 4 bytes. It looks at the next 4 bytes in that stack after the count parameter. It treats that as an integer and it returns it back to us here. And it moves the pointer, so there's a pointer inside this VA list 4 bytes over, okay? Those 4 bytes are now really iterated over, and the next time you call Vararg, it's just going to give you the next 4 bytes. If you, for example, if you call it with the int parameter here, you don't really have to call it with the same parameter type here. You can say char pointer or anything you want if you need to, but in our case we're using just integers. Okay, perfect, and then I can simply sum it to another variable. Let's say here int s equals 0, and I'm going to just add this value to s plus equals x. All right, and we're going to still return s. This can be removed, and that's almost everything. Let's not forget about va_n. So once we're done processing the whole argument list, we should always call va_n, and this guy just takes in the arguments, the va list variable that we have defined here. And now we're done. That's basically everything that we need to do to process this ... right? We have to start this processing of the va list, and then we can take each argument by specifying the type that we are expecting into, well, any variable or any context we might want. Great. Now, how do we call such a function? Well, we have this count here. So first we're going to have to specify here as a first argument the number of arguments we want to pass. So let's say in this case it's just 3 arguments. And then we specify the actual numbers that we want to sum. Okay, perfect. I can say 1, 2, 3 like before. And if I try to launch this, we should get sum is 6. That's the expected result. What happens if I add another one? So I can add 4 here, for example, but I'm gonna also have to change the count here. So I'm gonna also have to change the number of elements that I pass. Okay, and it certainly does work. The sum is now 10, and I can keep on passing as many as I want. So 6, 7, 8, 9, 10, and say here the number of arguments to be 10 in this case. And if I launch this, okay, it works perfectly fine. 55 is the sum. Now, to be able to use them, that's basically all you need to know. But I'm going to go into a couple more details regarding variadic functions. So first things first, there's something peculiar with this parameter count. Why do we need it? Can't we just have, you know, ellipses in the parameter list? Well, the thing is, the standard doesn't allow it. At least the standard up until C23, which is very, very recent, does not allow us to just have the ellipses there. You have to have at least one parameter defined in the parameter list. So you have to have at least something like an int count here. And this ties in nicely with the second interesting thing, and that is, why do we pass count specifically? Can we just pass in a garbage value that we don't care about or something like that? Well, not really. Vararg, as you might have noticed, it doesn't know how many parameters are there, and it will continue processing until you tell it to. And the key thing about it here is that if you tell it to process more parameters than there are, it's going to result into undefined behavior. And that's the kind of the big issue regarding it. It doesn't tell you, it doesn't return null, it doesn't return -1 or some error somewhere. It's straight up undefined behavior. If I change this to a 10, so instead, so let's say I ignore this count, I don't care about it anymore, and let's say I have here only 4 parameters, right? So I'm calling here sum with 4 variadic parameters, but I'm calling Vararg 10 times, right, more than the parameters that exist. Well, it's going to result in some undefined behavior. Right now it didn't crash, it's working, but it read some garbage value at the end of the stack that on some environments I might not have access to, and it would result in a crash. So not a great idea to do that. That's why I'm using here count, just so that we get the expected result, and of course this works again. And the third peculiarity is, do we always need to actually call this sum function and pass in the number of arguments? Is there any workaround or any better implementation doesn't need to do this? Well, actually there is. And we can try to, instead of passing in the number of arguments, we can pass in a null at the end, sort of a null terminator, but for the VA list itself. And this is a very common practice in C, actually. So we're going to create this function. Let's try to do this. I'm going to say here, I'm going to copy and paste this whole thing. I'm going to change it to sum, let's say sum2 in this case. And what I'm going to do is consider the first parameter as part of the sum. Okay, so it's going to be our A, whatever. I'm going to first initialize this S with the variable A, and of course here we're going to have A as well. And now we're going to have to change this a little bit. So first what I'm going to do is move this line here outside of the loop, all right? And we're going to first get an argument, and instead of a for loop, we're going to just use a while loop, and we're going to loop while x is not null. So while x is not null, and while x is not null, what we're going to do is add it to the sum, and then I'm going to read it again. Okay, and then this is going to stay the same with the VA end and return s. So I can call sum2 here. I'm going to say, instead of starting with a 4, we don't need that anymore. We can just say sum2 1, 2, 3, 4. And if we actually add the null terminator here and launch this, we're going to get the expected result. I guess the only issue with this function is that, remember, null is 0. Okay, so in our case, really what we're passing in here is 0 because we're taking in just integers. Okay, so you have to be careful because in some instances, so here, for example, of course, the GCC compiler is warning me because I'm comparing pointers to integers. In our case, we're actually going to have to compare it with 0 instead of null. It's the exact same value, doesn't really matter, but it's something to be aware of because in this specific example, it would break things if we were to add a 0 here at the sum. So if we were to add here a 0, if we call this and get the result, you will notice that it's free. So it only summed up until this 0. So once this 0 was met, well, it stopped summing. So in this specific case, it's not a great example, but if you are passing, for example, strings or pointers to other variables, then that's perfectly fine. Well, you're not going to have any issues because null is not going to be found as a pointer. So that's just another way of making variadic functions work. You can choose whichever implementation you want. You can use a count, you can use just a null terminator. There are some other ways that make use of macros so that you don't have to actually specify, let's say, the null terminator or the number of elements inside the variadic function call, so here in the printf. But I'm gonna let you research about this a little bit because it's a cool little implementation that you can do with your functions. So basically just create a macro that calls sum2 for you, and that changes the parameters a little bit. Alright, that's about it for this video. I hope you got something out of it. If you do have any questions, leave them down comments below or on our Discord server. Again, the source code for this video can be found on our website. There's a link in the description below. Take care. Bye.